Have you ever felt like your robot vacuum has a mind of its own? Like it's actually planning its route across your living room? Or what about when your phone sends you a notification for a pizza place, right as your stomach starts to grumble? That's not magic, and it's not a coincidence. It's the science of artificial intelligence. Now, for a lot of people, the term AI brings up images of Hollywood robots and scary sci-fi futures. It sounds complicated, maybe a little intimidating, with all this jargon like machine learning and neural networks. But what if I told you that by the end of this, those words won't be scary at all? What if you could finally understand how your little robot vacuum avoids falling down the stairs, or how your phone seems to read your mind? Today, we're going to pull back the curtain on the eye. We're not just going to define some terms. We're going to build a mental map, piece by piece, so you can see exactly how these incredible systems actually work. By the end, you won't just get it. You'll start to see the world around you in a totally new way. You'll understand that the intelligence in your devices isn't something to be afraid of, but a tool you're already using every single day. All right, let's start at the very top with the biggest and most misunderstood term of all, artificial intelligence. Or before we can get to the vacuum or the pizza, we need to know what we're even talking about. At its heart, artificial intelligence is a huge and amazing area of computer science. The main goal is to build machines that can do things that would normally require a person's brain. Think about what that means: learning, solving problems, understanding what people are saying, seeing the world, and making decisions. It's the grand dream of making computers smart. Now, we have to talk about the elephant in the room, the fear factor. When we hear AI, minds jump straight to the movies, thinking androids and super intelligent computers with their own plans. That's what experts call artificial general intelligence, or strong AI, a machine that would have the consciousness and brain power of a human. And let's be crystal clear, that is not what we have today. For now, it lives in the world of science fiction. What we do have, and what this is all about, is something called narrow AR weak AI. A better way to think of it is as a hyper-specialized, incredibly powerful tool. A great analogy is to imagine a super smart intern. This intern can learn from thousands of examples but never gets tired or asks for a raise. It can recognize your voice but won't ever judge your singing. It can recommend movies but doesn't care if you watch them. Each one of these A's is built to do one specific job extremely well, whether that's filtering your spam emails, translating languages, or, yes, steering a robot vacuum around your furniture. To really get this, picture a giant circle. That whole circle is the entire field of artificial intelligence, the dream of making smart machines. It's a concept that's been around for decades, a North Star for computer scientists. But dreaming of a smart machine and actually building one are very different things. For a long time, the question wasn't what I was, but how on earth you could do it. How do you get a machine to actually learn instead of just blindly following instructions somebody wrote? The answer to that how brings us to the next and maybe most important piece of our map. Inside our big AI circle, there is a smaller one that represents the most powerful way we create smart systems today. This is where the real revolution is happening. This is machine learning. So if AI is the big goal, machine learning, or ML, is the engine that's actually taking us there, it's a part of AI and it completely flips the old way of programming on its head. For most of history, if you wanted a computer to do something, a programmer had to write out exact step-by-step rules. If you wanted to catch spam, you'd write rules like, if an email has the phrase "you've won a prize," then mark it as spam. But this is a huge pain and breaks easily. As soon as spammers change the words, your program is useless. Machine learning changes the game entirely. Instead of us writing the rules, we let the computer figure out the rules for itself by learning from lots of data. It's a classic difference between giving someone a fish and teaching them how to fish. The best way to think about it is like teaching a dog a new trick. You don't sit the dog down and give it a PowerPoint on how to move its muscles to sit. You just say, sit, maybe guide it a little, and the second its butt hits the floor, you give it a treat. You reward the right outcome. After a few tries, the dog's brain connects the dots and forms a pattern. It learns what sit means from experience. Machine learning is a lot like that. The data is the experience, and a correct answer is the treat. Let's bring this back to your robot vacuum. An old, dumb vacuum just followed simple, programmed rules. Go straight until you hit a wall, then turn randomly. The result was chaos. It would bump into the same chair like 10 times, get stuck in a corner, and miss a huge spot in the middle of the room. It wasn't learning anything. Now, think about the idea behind a modern ML-powered vacuum. It's covered in sensors, its eyes and ears that are constantly collecting data. As it moves, its algorithm learns from what happens. If it turns left and finds a nice open stretch of floor, it gets a tiny digital reward. If it turns right and bumps into the cat, it gets a penalty. After thousands of these little decisions, the algorithm learns an incredibly good pattern for cleaning your specific room. It builds a map in its memory and finds the best path, all without a human ever telling it the layout of your house. That's the power of learning from data. This learning happens in a few different styles, and they're used for different kinds of problems. The three main types are supervised, unsupervised, and reinforcement learning. First up, supervised learning. This is the most common type, and it's like studying for a test when you already have the answer key. You feed the algorithm a ton of data that's already been labeled with the right answers. Your spam filter is the perfect example. Engineers show the algorithm millions of emails that have already been marked by people as spam or not spam. The algorithm chews on all this data and starts to learn the subtle patterns, certain words, weird links, strange sender addresses. After its training, when a new email arrives, the algorithm uses what it learned to make a really good guess, spam or not spam. Second, there's unsupervised learning. If supervised learning is studying with an answer key, this is like being dropped into a foreign library and being told to sort the books by subject. The data has no labels. The IDA's job isn't to guess a correct answer, but to find its own hidden patterns and groups in the data. This is exactly how your favorite streaming service's recommendation engine works. Netflix doesn't really know why you like certain shows, but its algorithm can sift through the viewing habits of millions of people and find clusters of users with similar taste. It sees that people who watch Stranger Things and Black Mirror also tended to really enjoy The Witcher. It doesn't know they're all sci-fi or fantasy. It just knows the viewing patterns match up. So, because you're in that group, it suggests The Witcher to you. It found a hidden pattern and put it to use. Finally, we have reinforcement learning. This is the trial and error method we saw with the robot vacuum and the dog. It's all about learning by doing, driven by rewards and punishments. This is the secret behind it, is that can master incredibly complex games like chess or Go. The AI isn't taught the best strategies. It just plays against itself millions and millions of times. It gets a +1 for winning a game and a -1 for losing. Over these millions of games, it discovers strategies so brilliant and strange, they often go beyond what human players ever thought of. It learns by doing. So, machine learning is how the computer learns from data. But what's the actual machinery inside the computer that's doing the learning? What's the brain that finds all these patterns? That brings us to our final, deepest layer, neural networks. Okay, we've got the goal and the method. Now we're going down into the engine room to see the machinery that powers it all. For the most impressive things the eye can do today, that engine is an artificial neural network. The name itself gives you a big clue. These systems are inspired by the way our own brains are built. Your brain is made of billions of cells called neurons, all connected in a giant, complicated web. An artificial neural network copies that idea by creating a network of digital nodes, which are like artificial neurons. Just remember, it's an inspiration. It's all math, not biology. To make this simple, let's use the classic sandwich analogy. A neural network is organized in layers. You have an input layer, which is your bottom slice of bread. This is where all the raw data goes into the network. Then you have one or more hidden layers. This is the stuff in the middle, the lettuce, tomato, cheese, all the good stuff. This is where the real work and thinking happens. Finally, you have the output layer, your top slice of bread. This layer gives you the final answer, the decision, or the prediction. Let's put this into action and finally solve the mystery of your pizza predicting phone. The input layer gets hit with all the raw data points from a specific moment. Things like, the time of day is 7:03 p.m., the day is Friday, your phone's GPS says you're at home. Your recent Google searches include best pizza deals. You opened a food delivery app 5 minutes ago. All these little facts are fed into the input nodes. Now that data flows into the hidden layers. Each little node in the first hidden layer looks at the inputs and does a tiny calculation. On its own, it's not very smart. One node might just be trained to perk up if the time is after 6 p.m. Another one activates if the day is a Friday or Saturday. A third might notice that your location hasn't changed in an hour. They're all just looking for simple little signals. But then the results from this layer get fed into the next hidden layer. And this is where the magic starts. The second layer can combine the simple patterns from the first. One of its nodes might learn to activate only when the It's Friday node and the He's at Home node and the It's Evening node are all firing. Suddenly, it's learned a more complex idea. Friday night at home. Another node might combine your search history and app usage to learn the concept he's planning to order food. The more hidden layers you have, the more complicated the patterns the network can learn. This whole process of information flowing through the network is called forward propagation. Finally, all this refined information gets to the output layer. Let's say this layer just has two nodes, wants pizza and doesn't want pizza. Based on the powerful combined signals it got from the last hidden layer, the wants pizza node lights up with a very high score, say 95% certainty, and that is what triggers the notification on your phone. It wasn't one thing. It was the network's ability to weave together dozens of tiny signals into one very confident prediction. This brings us to our last bit of jargon, deep learning. And now it's super simple to understand. When a neural network has lots of hidden layers, a really thick sandwich with tons of fillings, it's called a deep neural network. The technique of using these is called deep learning. That depth is what lets an AI learn incredibly complex patterns from huge amounts of data. It's what you need for really tough jobs like understanding all the little details of human speech for a voice assistant or identifying a dog versus a cat in a photo with near-perfect accuracy. There are even specialized neural networks for specific jobs. Two you might hear about are convolutional neural networks. Think of these as the eyes of an eye. They are rock stars at processing visual stuff like photos and videos. They are the reason your phone's photo app can automatically find every picture you have of your dog. Recurrent neural networks. These are the ears and memory of an eye. They're built to handle data that comes in a sequence, like words in a sentence or notes in a song. When you type, "I'm feeling really ... and your phone suggests the word hungry. That's an RNN remembering the start of your sentence to predict the end. So there's our map. From the big idea of an eye down to the method of machine learning and finally to the engine of neural networks. Now that we've seen how it all works, you might be thinking this is all a bit abstract. But the truth is, you are bumping into these systems hundreds of times a day, and you probably don't even notice. Isn't some future tech. It's already woven into our daily lives. Let's just walk through a normal day with your eye sidekick. You wake up, maybe to a smart alarm that tracked your sleep and woke you up at the perfect moment in your sleep cycle so you feel refreshed. You glance at your phone and it unlocks instantly with facial recognition, which uses deep learning to analyze your face. You ask your voice assistant, like Siri or Google Assistant, for the weather. In less than a second, an RNN processes your speech. A deep learning model figures out what you want, and another system finds the answer and speaks it back to you. On your commute, you fire up Google Maps or Waze. They use machine learning to look at live traffic data from thousands of other drivers, predicting traffic jams before they even happen and changing your route on the fly. And the development of fully self-driving cars is one of the biggest challenges in AI, using a whole collection of models to see and navigate the world. At work, AI is your invisible coworker. Your email automatically sorts messages for you. Other tools can summarize long reports, check your grammar, and even suggest lines of code while you're typing. Then, in your downtime, AI is the ultimate curator. The feed you see on social media isn't in order. It's a personalized stream built by an algorithm that's guessing what you want to see most. When you chill with Netflix or Spotify, the recommendations are coming from unsupervised learning, which has found your taste profile to suggest your next favorite show or song. And this goes way beyond our personal lives. This same technology is having a huge impact in really important places. In healthcare, AI models can look at medical scans like X-rays and MRIs and spot signs of diseases like cancer, sometimes even more accurately than a human doctor. In finance, AI is the silent security guard on your bank accounts, analyzing millions of transactions a second to spot fraud, which is why you get an instant text when a weird purchase shows up on your card. From the simple to the world-changing, AI isn't Horizon, it's here. It's in your pocket, in your home, and in your car. It's a quiet revolution that has already changed our world, one smart prediction at a time. If this journey from AI to machine learning to neural networks has helped clear up the tech that's shaping our world, think about hitting that subscribe button and ringing the notification bell. We put out explainers like this every week, breaking down the complex science that's all around us in a way that everyone can understand. So let's zoom back out. We started with a couple of mysteries, a smart vacuum and a pizza predicting phone. Now you have the full map to understand them. You see that artificial intelligence isn't one single thing. It's the big, ambitious goal. Machine learning is the main strategy we use to get there by letting computers learn from experience. And deep learning with neural networks is the powerful engine driving it all, a brain-inspired system that can find almost any pattern. AI isn't magic. It's a tool built on these logical layers. The robot vacuum isn't just lucky. It's using a learning process to find the best path. Your phone doesn't have a sixth sense. A deep neural network is weighing dozens of data points to make a very educated guess that you might be hungry. By understanding this, you're no longer just a user of this technology. You're an informed participant. You can look at the world and see the systems at work. The fear fades and understanding takes its place. The world is only going to become more shaped by this technology. And knowing how it works is the first, most important step to being ready for that future. It's not so scary when you know the secret, is it?